Today's lesson is about the different types of interest. We're going to talk first about compound interest. This is a formula that you need to know and understand how to find and work. Okay, a lot of it can be put right into your calculator, but you got to know what parts equal what. So this is A, which we're going to stand for the balance after some time, or the amount that you would have in an account after some time. P is your principal. This is the beginning amount or the initial amount that you put into an account, or maybe that you borrow from an account to pay something. 1 just stands for, obviously, if you put it in, you have it, so you have one full amount of it. Or if you borrow some money from someone, they expect that money back plus some interest in most cases, especially from a bank. The interest rate, you're going to know that you put it in as a percentage. Has to be changed to a decimal, so you have to put it in as a decimal. Know how to do that. Just moving your decimal place 2 spots to the left helps you there. N is the number of times interest is compounded for how many years we're talking about. So if we're talking about annually, that's only once. If we're talking about monthly, that would be 12. And then T stands for time in years. So there is a little frequency table here to give you some breakdown of what N would be if we were talking like quarterly or monthly or daily, hourly, or even every minute. So we're going to do a problem together. These that we're doing in this video are very basic. You will have to get more complex, where you will be finding maybe what T is worth or N is worth or what P is worth when given other values. And that's where you will have to use your knowledge of logarithms to help you. All right, we're going to look at the first one. Larry invested $27,000 in a savings account that pays an annual interest rate of 1.8%. The savings account is set to compound quarterly. How much is Larry's account after 5 years? So let's start with what we know. He's putting in the $27,000. So that's going to be our initial amount, or our principal. It's an annual interest rate of 1.8%. So this is our rate. And we are going to need to change that to a decimal. So right now it's 1.8%. Our decimal's here, 2 spots. So we will actually put into our formula as decimal 0.18. And it's compounding quarterly. Quarterly here, we can see in our chart here, is 4 times. So our N is going to be 4. And then we want to know after 5 years. So our T will be 5. So let's plug it into our formula. A is equal to, P is the 27,000, the one that we have to give back, plus our rate that we've already changed to a percentage, or to a decimal, excuse me, divided by our number of times that is compounding, so 4 times per year, quarterly, raised to the number of years times how many times we're compounding. So N, again, times 5 for our years. And when I put this in my calculator, I put it directly like I see it. 27,000, parentheses, 1 plus. I will put a parentheses around this in my calculator with another one, and then raise to, and sometimes if you know that one really easy, go ahead and put it in as 20. And then what will come out may need to be rounded to the nearest cent, but we will get here $29,536.74. And we can see if they ask us how much we would have in the account at the end, this would be our answer. If they ask us how much did we make on our investment, we would have to take our initial amount, the $27,000, away from the $29,536, and we would see we'd make about $2,536 on our investment for it just sitting there for 5 years. This takes into account no adding money, no taking away money, just literally putting it in there and forgetting about it for that 5 years with interest rates staying consistent. Now, the other type that we're going to deal with is called continuous interest. And this is where we have that letter E. We know that that is actually a number. It's a mathematical number. It's roughly 2.718. And we know that through studying, this is actually a letter that has a number, but it was actually named after the person that discovered it. So bonus question built in. If you do a little bit of research, you find out who actually discovered that and who that's named after and what he did. So send me an email and let me know what you found out about him, at least a couple cool facts, and his name, and maybe something else he had involvement in, and you'll get some bonus points there. But this is a number, and so on our calculator, we know this is a natural log, so we have a button that's LN. Right above that button, so we have a little button there, right above that button, there's a little E with an X. Now in Desmos, you can see just the E and then the E with the exponent there too. We're going to use that second function with the E with the X on our calculator to do this, but this is when money continuously compounds. So the more we compound, the more we make, but when we get to a certain point, it's going to kind of level off. And we might make a few cents more, but it's not really a big change. And that's where financial institutes use this formula to kind of give you an overall view in your statements and to kind of take out the bumpiness of the real world that happens around us and to kind of give you a clean, nice number. This is the most that you could ever make on a certain investment, and it gives you kind of an idea what would happen if you had continuous compounding. So we're going to do a very simple problem here. You're investing $1,000 at an annual interest rate of 5%. So we have our P here. We have our rate here as a percentage, and it's compounded continuously. So when you see the word continuously, you know that you're going to use this formula. Calculate the final amount you will have an account after 5 years. So this will be our time. Okay, so then we're just going to plug it in. We do not know A, that's what we're trying to find. Our P is 1,000. Our E, our E is E. And it's raised to the rate, which is 5%. And our decimals here, we got to move it back 2. So we got 0.05. That's what needs to put in for our rate into our formula. 0.05 times 5 years. And we're going to literally put this straight into our calculator using the E button. It will actually say E on your calculator, and when you plug it in, you will get $1,284.03. So this would tell you that just for it sitting there continuously for 5 years, compounding at 5% annually, you would make $284.03. Your goal of this is to be able to solve for different parts that you may be given and solve for the unknowns, and also to be able to compare compounding versus continuously under certain times and when's a better deal, which one should you choose, and also be able to see what these look like on a graph.